All right, welcome to week 3. We just did a little recap of what we did last week with interactive objects, object specialization by composition, and we reviewed some of these classes. We started writing some scripts. I think the one we did the most interesting work on was object spawner. So if we review that, we had this thing called spawn logic. Visual Studio will do some work. All right, and just to review, this thing makes a copy of whatever game object reference is in this public field OBJ. Right, a game object is a reference to any game object in the hierarchy. And so how do we connect this reference? Because this is null until you initialize it. How do we initialize OBJ?
It's actually like a UI.
It's actually at design time in the inspector. You're right. So we do that by drag and dropping a reference to something in here. And we make an effort to make sure that the game object we're copying is one from the project tab and not one from the hierarchy. Why? What's the difference? What's the difference between game objects in the project tab versus game objects in the hierarchy? Because Nerf bullet here, that's a game object. That's a certain kind of game object. And, this tower is also a game object. But there's an important difference. The ones in your hierarchy, this is your actual scene, this is your actual simulation. When you play and run your game, these are the entities that are updating. In the project tab, these are your assets. Textures, sounds, models, and also prefabs. What's a prefab? We did it last week. Yeah.
An asset that you made yourself.
It is. It's a template for a game object, and it looks like a game object. So Nerf bullet is a prefab, and you'll remember that it's got a bunch of components on it with a bunch of properties that you've adjusted and then serialized and saved off, so that when you want to make a copy of that again, you don't have to go and do all that work again. You can just make a duplicate of that thing. So it's like a blueprint in some sense. So if we're always making a copy of our blueprint, then that means we know we're always going to have a blueprint. You can't delete your blueprint at runtime, but it's real easy to, while your game is running, accidentally delete a game object. So it would be a shame if your code depended on something that's not predictable, So we always make sure when we're doing this kind of projectile work, at least, that it's from an asset you'll always have. Okay. Let's go back to this thing. So I think it was connected to the spacebar, and these things collide with each other and they fall off. But if you shoot them at a reasonable speed, you got something that's like a missile launcher. Let's extend this project a little bit further. What if our object spawner was going to end up being a ship? Let's say we want to extend this into some kind of a shooter. How could we give our ship a visual representation? Because right now, it's just an empty game object. Well, you remember, it actually does have, if you look at the components, it does have a sphere mesh, it does have a mesh renderer, but the mesh renderer is off. So there's a small game object there. If we wanted to make this into a ship, what could we do? What could we add to this game object in order to improve its look without recreating it from scratch? Well, one thing we can do is we can use the hierarchy, and we can add sub-objects, right? So I made another cube. I'm going to zoom in. Let's make this look like a ship. How can I make this? Let's say I want to make this a wing. What could I do to make this more wing-like? Yeah, let's do something like that. Let's say 0.2. Let's move that over there. Maybe we'll rotate it 45. I don't know. Do another one. Put that over there. Is that a ship? Maybe. I think it needs a front. Generally speaking, for you know, and to identify with a game object, you need a facing. You need a direction with it, even if you're just prototyping. So we'll call this like the nose, the front. We'll set that to 0, 0, 0. Why is it when I set the front 0, 0, 0, it's not actually at 0, 0, 0 in the world, but it's sort of sitting on top of the sphere?
Position is relative to the object's point.
Very good. So I'm going to go 0.2, 0.21. I'm going to slide it forward just a little bit. So there's my front, okay? It has a box collider. I don't need that component. And the wings, they don't need a box collider either. We don't want them to have colliders because we don't want the bullets colliding with the ship and flying off in a weird direction, the way our code works right now. So I like that. And if we scale it up, it should appear a little bit bigger. If we play this, there's one bullet in the scene automatically, but we can at least spawn the thing. And if we move our ship over, so they're still coming out of it. They're not necessarily spawning at exactly the right spot, but we're going to fix that. Okay. So what if we wanted to make our ship move under user control? Because right now we're editing it, editing its transform to prove that the bullets are spawning in the right spot. How could we make that interactive? I'm going to make a new component called ship movement. I'm going to attach it to my ship. There we go. And we're going to say moves the ship under keyboard control. So if it moves the ship under keyboard control, what are we going to need? Some keys to read for movement, right? So what was the data type? What was the variable type for a key that we were listening to? We did it for instantiate. Yeah. Say that's left, and say that's right. You know what? I'm going to change this. We already done key codes. Let's do something else. The input manager, in addition to reading keys, we can also read buttons and we can read axes. And I think I talked about this on the whiteboard last week. A button is something on the gamepad that you can press. It's not a key unless it's a keyboard. And an axis is like an analog stick that you can either move left or right and up and down. Does everyone have Xbox or PS4 at home? You know what I'm talking about by gamepad? Anybody not sure? Okay, great. So I'm going to say vector 2. And I'm going to say some axis values to read for movement. And an update, we're going to write a little function here because we never put our update logic directly in the update loop. So ship movement update. Grab axis from input manager. So we're going to say axis dot. It's a vector 2, so that means it's got two components, x and y. we're going to say that the x component of this thing is the, well, when you think of the x-axis on a two-dimensional graph, would you typically think of that as horizontal or vertical? It's horizontal, right? So we're going to say input manager dot get axis. Hey, cool. What's that thing do? Returns the value of the virtual axis identified by axis name. We'll look in the input manager to see exactly what the name of it is, but luckily for us, we get something automatically called horizontal, which reads the primary horizontal axis off whatever device you have plugged in. Okay? If you have a gamepad plugged in, this will give you the horizontal. And same thing for vertical. Because those are public, right off the bat, I'm just going to switch back here. We're going to look for ship movement to serialize that script. We're going to see axis show up. Now I've got X and Y. They're default to 0 because we haven't assigned anything to them. But because every frame we're polling the input manager, I'll show you input manager right now. It's under project settings, input, axes. You get all these axes and buttons defined by default: horizontal, vertical, fire 1, 2, 3, jump, submit, and cancel. So this thing will automatically bind itself to the x-axis off any joystick, but also the left and the right keys on the keyboard. So because I'm on a PC, I can use horizontal and I can read it like a virtual axis with the left and the right arrows. And the same thing for vertical. I can read it for the up and down arrows. Also, AS, DNF, as you can see there. You can definitely add your own axes if you plug in other devices, if you have a steering wheel or some other USB HID device, and you can configure it in there. And then you can get it with the string that you name it. So we're going to get the value from the string vertical, because that's its name, and the string horizontal, because that's its name. So we run. If I press left and right, notice the X property on the ship movement component. If I push full left, it goes all the way to -1 and then stops. I'm just holding the left arrow. If I let go, it lerps back to 0. So it's like it bounces back. It has a string and a spring on it, and it wants to go back to the dead zone. If I push right on it, it's like I'm pushing right on the stick. It goes up to 1.0, and then I let go. So it's bound between -1 and 1, and 0 when I'm not touching it. Same thing for vertical. If I push up, Y goes up to 1, it goes back to 0. If I push down, it goes to -1 and back up again. Cool? So we're going to use that to drive the movement of our ship.